Hello, and this is part 2 of my CS2 external cheat. Now, in this video, I was planning to make a trigger bot, but I thought it'd be a better idea if I'd make a simple bhop script. So let's actually hop on into a practice game real quick. And let's go and open up Cheat Engine. Okay, once in Cheat Engine, we're gonna attach to CS2. As always, over here, cs2.exe. No, we're not going to load that. It's not going to ask you that. Once again, that is just a cheat table I made. And now the first thing that we should do is scan for our local health. It's going to be much more quicker because I don't have to explain every single step. Once again, we're just going to scan. It's a 4 byte. So now I'm going to decrease my health. I saw in the last video, if I decrease my health by 11, I'm going to get a few answers. So here we go. We found 16. So now we can access some of these addresses. From what I remember, I might find it. Yeah, okay, I just found it like instantly. Okay, so this is it, because if you see here, this will open up the Windows debugger attached to that memory address, and it's gonna see what's changing it, what is writing it, and what is reading it. And we can see here that there's some read functions, and here this is our offset 31C, like I said before. Now, in assembly, these are registries. Each registry holds some values, holds some information. Now, from what we can see here, if you press for this, for example, registry RCX is this number over here. Now, if you take a close look, let's look. It ends in 800 and starts to 66. We go to this one, and we look at RBX this time, and it's the same. Now, last video I said this again. These registries over here represent the local player base pointer address. So basically, these registries hold the value of that. So yes, in last video we used the pointer scan to find the local player pointer, static pointer with the relative offset. Now in this video we can use this. So we can go on each one of them. But you just gotta go to the right registry. So in this case we go to RDI. Let's go to RDI real quick. We get this. We don't care about the zeros. Zeros don't represent anything if they're behind the number. So now what we're gonna do, we're gonna press on use scan. We're gonna change it to hex because memory addresses are hex notated. And we're gonna paste this address over here. So now we're gonna just press for scan. We're gonna get a lot of values. We're gonna have 701. But as I remember, this is the address for our static pointer. Static pointers don't change. And Cheat Engine annotates the static pointers with a green color. So we should actually search from it like this. And bingo. Here we go. Boom. Okay, we found them. Here we go. You can see we have here the relative offsets with relative from our base, from our module base address. And we can get both of them. Now, why are there two? Well, because in CSGO, there is one local player and there's one entity. Now, if you want to find out which is which, we can, for example, add a bot, and then we can check by shooting him, and then doing the health check, and then doing a pointer scan for that. And you're gonna see that you're only gonna find one, and that one will be the entity. So I already know this, which is which. So actually, let me just press on it. Let's check. So this one over here is the entity pointer for all the entities on the map. Of course, it's going to also show my health. It's going to point to my the value that it holds is also my health, because I'm the only entity on this map right now. If we look at its class, you're going to see all the entities listed logically, and it will have an inheritance from the local player class with all of the information like health and all that good shit. So now we're gonna delete this because that is only entity. And now we have our pointer over here, our local player pointer. Now, what do we need to get bhop? Well, first of all, we need actually just two more things before we start coding. Well, in CSGO, there's this, when you jump, there's this variable that changes each time you jump, you crouch, or you crouch jump. This is called FF flags, MFF flags. Well, what does this mean? It's basically, it's to your local, it's to the entity class, of course. And it basically checks your current state, if you're jumping, if you're crouching. Now, in CSGO, there is the offset for that. Okay, of course, we know it because we have such as haze dumper. But the value in CSGO when you jump or like crouch is much more different to the value in CS2. So in CSGO, you'd usually just scan for the value that you know in cheat engine of crouching and jumping. But in CS2, you gotta scan for an unknown initial value. So to do this, we're gonna need to set up a little thing, a few things. So now let's just delete this real quick. And we're gonna, okay, we're gonna put it to a no initial value. It's a 4 byte. We are not sure if it is a 4 byte, but it's pretty safe to assume that it is a 4 byte. Now, next thing that we want to do, because we want to scan when our player is jumping, and that jump state is not forever, really. So we would basically need like a hotkey that would basically scan instantly when we jump. Now, we're in luck because Cheat Engine is such a wonderful and powerful app. We go to settings over here, and we go to hotkeys, and you can see over here, new scan exact value, new scan. Well, we're gonna go to new scan, change value, and we're gonna put it to P. In this case, I already put it to P, and our next change value, it can be B, it can be whatever you want. I'm gonna put it to V. Actually, I'm gonna keep it to B. It doesn't matter. It doesn't matter really. You just need a keybind, which is clear. So now this makes our life so much easier because we don't have to tab out and then press next scan very fast. So let's actually start this. So we already did that. We remember that P is change value. So for example, we crouch and then we're gonna press P change value, and you're gonna see that it's gonna work. Let's just put it like this so you can see all the addresses. Okay, so so the value got changed when we crouched. Okay, so now we have another change value because we uncrouched. We only have 8 million results now. So now we're gonna press P, which means that it's a not change value. And we can repeat this because some variables, memory variables, they change automatically. For example, when you move, some of them, they turn red when you move. So then we can press B while you're moving. It's gonna remove all the useless shit because your current state is still the same. You're not jumping. Now, look at those green ones. They're not even moving. So actually, to remove them just because they're pissing me off already, I'm just gonna remove this shit. So now, let's see. We're gonna jump. Oh. Okay, we only have 5. Almost there. Okay. Which, but look at this. If we take a closer look at the first address over here, when we crouch, okay, it turns a value, but then when we uncrouch it, there's another value, and then goes back to its original value. So it's basically going through 3 values. So So that's not our case because we're not doing three things at the same time. We're just uncroaching, so it should be just a change between two values. Just gotta be really careful. You see that? Okay. This is clearly not it. And now, looking at this big ass number, we can just honestly assume that it's not it. Because it's pretty huge. But it's very dangerous to do this because we don't know. So we're gonna take all of them actually. We're gonna put them here. And now, one way to do this, one way to safely assume which is which and which is the good one to use, is if we take a look at the addresses. Addresses are allocated based on numbers. The furthest, the higher the number, the more far away it is. RBX. And now let's make an address manually. We're gonna put this address, and this is gonna be doesn't matter. Okay. So now let's take a look at these. So these are the ones that we found. They're all very, very close. So one way now, how do we find the offset of this? Well, actually, we can either actually go to RCX. I'm really curious to see this. RCX and check if this is our matching. This is not our matching. See, this is much more different because over here we don't have a 951, and we clearly know, that this is a local player. So maybe this is towards an entity. So if it's not this, then let's look at this one. Oh, that's a lot of command. And let's go to RAX. Look at this one. Well, look at this one. It's literally the same one. So this might be it. So now let's change the description to MF flags. Just so we have a filter, really. And now let's check the last one. There should be an offset here, which means that it's clearly not it. Our MF flags is this one because it has matching. It does have matching over here. We can go ACX, for example. Oh no, Rax. What the fuck am I saying? It has matching local player pointer address. Now this is the offset for sure, 3B8. Now there is another way to get offset. You open up Windows calculator, you change it to hex, and you subtract this the address of this variable over here, the MF flags, with the local player, which will give you the difference between the local player and MF flags. So now let's delete all of this bullshit real quick. So now the next thing to get in to get the bhop is force jump, which basically in CSGO there's this function called plus jump that if you write in console is gonna make you jump. Now for my case in CS2 is the same thing. Plus jump is gonna work for you. For me it does not work because I bind it plus jump with my scroll key, which kind of glitches it out, but we can still find the offset of the plus jump anyway. We just need to be a little bit careful. So now let's position our windows perfectly. So we're going to start once again with unknown initial value. And we're going to go with first scan. Pretty safe to assume that it's a 4-byte. Next, once again, we're going to write plus jump. Now, it should make you jump here. Even if it doesn't, it's okay. I can't jump if I press my spacebar right now. So, yeah, it's clearly working. Now we're gonna press on unchanged value. Change value. I'm not gonna. I disabled the hot bind for this case because it was P and jump has a P inside. Okay, now there we have all of these stupid values that keep changing like every single second. Now let's just scan multiple times until we get rid of these annoying values because we don't really need them at all. Now change value. Next, we're gonna write minus jump, which basically takes away a byte. I think, I'm pretty sure, a byte from the original value of jump. So basically, when you jump in the game, it gets turned. There is a value set to that. Plus jump has a value of its own. For example, if it's set to 1, it activates the jump. Works similar with FF flags. Okay, change value. Now we will write plus jump again, and let's do this thing again with the change value. See, it's going pretty. CSGO, some variables, for example, are some functions are part of the same family. Same family, I'm saying that they're very similar. Plus attack, plus jump, plus attack 2. They're kind of the same. And look at this. The values turned red, so they changed compared to my last scan. Just because I moved a little bit. Some variables are based on that. Some variables are based on the fact that in which team you are, and what health you have. So even, for example, when you're stuck like this to 12,000, for example, you have to move around. You have to play the game a little bit. And you have to go to basically. See? Those values, see, now they're going back to normal. But when I move, they go back to red. So now let's try and get rid of those. When I crouch, let's see. Those turn to something. We do not want that. Let's use the keybind for unchanged values, so we get rid of those. They're very useless. So now we can actually even change the teams and still scan for an unchanged value. It's gonna bring down those to a few hundred lower, a few hundred more finds lower, but that's okay. Now put it to changed value. Once again, start again. Plus jump. Unchanged value. Let's activate plus attack. And see all of those, how they turn red? Because they were turning red when I was jumping, but they were also turning red when I used the plus attack command. So we're not searching for that. And look, we're down to 54 only. Oh, plus attack, minus attack, minus attack. Actually, before I write that command, let me just run this one more time. So I'm sure, no, minus attack. Still not changed. Nice. 22 only. Now let's see, plus jump. Let's see, we ended in plus jump, so we're gonna go minus jump. Now, when we're searching for like one of these kind of related functions that you, for example, you type inside the console, that is like a level 1. That is 100% linked to your client.dll. It cannot be part of a class. It can't be part of your local player. It's not a function that's in a class or whatever the fuck. It has to be linked to your client.dll. So we need to get a like static address. So static addresses, I told you already, they're green. So over here we have the green ones. We have a few actually. So let's actually put all of them. I put this one over here because I actually know it works. Because I already tried and I failed multiple times, but now I found it. There's multiple. Okay, so let's see. We have 3. Let's add up all of them. Now, look at this big ass value. Jump. No. Yeah. Need to activate my jump. Okay. So, see how they turn a value on jump. That value stays the same, which is actually good, except for the middle one. it has changing values all the time. You see that? This guy over here. Look, ends in 24. I jump, 36. 40 this time. This guy is not the thinker. Get the fuck out of here. Now, it's between these two fuckers. Now, this guy starts from 0. Normal. This guy starts from 255 to 256. Abnormal. But they both seem to work. So, it's actually copy addresses. Let's see. 106 6. 106. So see, we write to this one and nothing happens, which sucks. So we delete this one, and guess what we're left with? We're left with this one, 256, and when we jump and we hold spacebar, it gets turned to 65537. So let's go. 65537. And boom, we jumped. And now let's put it back to 256. I really don't want to know what's going to happen if we don't put it back to 256 or whatever the fuck. So we got our plus force jump command. Now let's actually code our bhop. So now first I'm going to make a while loop. As always, we're going to start in a while loop, and I'm going to sleep it, and then I'm going to define the local player, the flags, the jump, and we're gonna basically be chilling. So let's actually do this. So here we check if we get the local player. If we don't get the local player, we're gonna continue. I'm holding my microphone in my other hand. If it is gonna be true, so if we don't have the local player, we're gonna continue. Which that means that over here the compiler, over here, the while loop stops in its tracks, and then it restarts from the beginning and repeats this cycle until you find the local player. Basically, if the Windows detects that you press space, you hold space, you press it, or anything. If you touch space and flags equals to 65665, which means that you're on the ground, then you execute the memory change, which will make you jump. So you either use a bit mask, which detects a bit change, in this case like a 1-bit change, because that's the case for us. If we jump once, there's going to be one change between bytes. So I think that's cooler. So now we finally have it. In this case, I used a bit mask. I guess it's the usual bhop you find, the simplest bhop you find around. You can also just check by manually writing the value for the ground. But if we run it, everything is gonna work. Hopefully. So it's running. I didn't want to make a new. So now if we hold space, see that you're jumping perfectly.